Hello students, hi everyone. I hope everyone is doing great. Today we are going to discuss about one of the JE question which is given on January 2024 30th January evening session. The question is, consider the system of linear equations and three equations are given: x plus y plus z is equals to 5, x plus 2y plus lambda square z is equals to 9, and the third equation is x plus 3y plus lambda z is equals to mu, where lambda comma mu are real numbers. Then which of the following statement is incorrect? You have to remember this one. Students hurriedly will take the correct option, but this question is which of this statement is not correct. We have to select an incorrect statement. Now we will solve this question step by step. So if we just look at the options, they are asking about infinite number of solutions and consistent, inconsistent, unique solution and all. Now let's find the value of lambda. To find the value of lambda, put delta is equals to 0. Delta is nothing but det of a. So det of a is what? Determinant of 1, 1, 1. Next is 1, 2, lambda square, and the third row is 1, 3, lambda, which is equals to 0. Dissolve this determinant. If you dissolve this determinant by row 1, 1 into 2 lambda minus 3 lambda square minus 1 into lambda minus lambda square plus 1 into 3 minus 2, that is equals to 0. So 2 lambda minus 3 lambda square, take negative sign inside the bracket, minus lambda plus lambda square, 3 minus 2 is plus 1, which is equals to 0. So if you solve this one, minus 3 lambda square plus lambda is minus 2 lambda square, plus 2 lambda minus lambda is plus lambda, plus 1 is equals to 0. Multiply negative sign on both sides, then we will get 2 lambda square minus lambda minus 1, which is a quadratic equation. So 2 lambda square minus 2 lambda plus lambda minus 1 is equals to 0. Take 2 lambda common, then we get lambda minus 1. Next take plus 1 common, lambda minus 1 is equals to 0. Take lambda minus 1 common, then we will get 2 lambda plus 1 is equals to 0. So the possibilities are lambda is equals to 1 and lambda is equals to minus 1 by 2. So when you take lambda is equals to 1 and lambda is equals to minus 1 by 2, we get delta is equals to 0. System is inconsistent. You have to remember this point to check which option is correct and which option is incorrect. Now we need to find another value, mu. To find mu, what we need to solve is, we need to solve delta 1. Now delta 1 is equals to, put delta 1 is also equals to 0. Delta 1 is nothing but replace first column by 5, 9, mu. So 5, 9, mu, and remaining two columns are as it is. Remaining two columns are 1, 2, 3 and 1, 1, 1. Take lambda is equals to plus 1 in this case. Here we got lambda values 2, no? Lambda is equals to 1 and lambda is equals to minus 1 by 2. Take lambda is equals to 1 in this case. Now dissolve this determinant. 5 into, remove this row and this column, so 2 minus 3 minus 1 into 9 minus mu plus 1 into 9 3 is 27 minus 2 mu, that is equals to 0. Minus 5, take negative sign inside the bracket, minus 9 plus mu plus 27 minus 2 mu is equals to 0. Plus mu minus 2 mu is minus mu, minus 5 minus 9 is minus 14, minus 14 plus 27 is plus 13 is equals to 0. That implies mu is equals to 13. So this is the value of mu when you put delta 1 is equals to 0. Similarly, try to find delta 2. Delta 2 is as usual, first row is as it is, first column is as it is 1 1 1. Replace second column, this is column 2, no, replace second column by 5 9 and the mu value is 13. Next last column is as it is 1 1 1. The value of this determinant is also equals to 0, because if any two rows or two columns of a determinant are same, then the value of the determinant is 0. We have to use that property in determinants. Similarly, we will solve delta 3. Delta 3 also equals to 0. In delta 3 also we get two similar columns. If any two rows or any two columns are same, then the value of the determinant is 0. When you just look here, we got lambda is equals to 1 and mu is equals to 13. When you get these things, delta is equals to 0, delta 1 is equals to 0, delta 2 is equals to 0, delta 3 is equals to 0. With this condition, you will get infinitely many solutions by Cramer's rule. Now we will check the options one by one. First, look at the first option. The first option is the system has infinite number of solutions if lambda is equals to 1 and mu is equals to 13. This is correct statement. See, when I take lambda is equals to 1, mu is equals to 13, we get infinitely many solutions by Cramer's rule. Next, look at the second option. System is inconsistent when lambda is equals to 1. Yes, system is inconsistent when you take lambda is equals to 1. We already written system is inconsistent. And mu not equals to 13. Yes, this is also correct. Next, system is consistent if lambda not equals to 1. This is also correct statement. When you take lambda not equals to 1, then delta not equals to 0. When delta not equals to 0, automatically system is consistent. There is no other word in it. This is also correct. When you look at the last option, system has unique solution if lambda not equals to 1 and mu not equals to 13. What you have to look here is here we got two values for lambda, not 1. Lambda is equals to 1 and lambda is equals to minus 1 by 2. These are the two values we got. System has unique solution if lambda not equals to 1 and lambda also not equals to minus 1 by 2. This should be there in the statement, but they gave only lambda not equals to 1 and mu is equals to 13. So automatically this option is incorrect. So option 4 is correct for this particular question. Option 4 is correct. I hope you enjoyed this video a lot. If you like this video, please like, share and subscribe. Give some motivation for us. Thank you.